Welcome to the Deep Dive. Today we're doing a crash course in high-fidelity video phase swapping, or VFS. And if you've ever really looked closely at a deepfake, you know the biggest issue. It's that moment the person turns their head or, makes a big expression.
And the whole thing just falls apart.
Exactly. The face flickers, the identity breaks, the consistency frame to frame is just not there.
Okay, let's unpack this. We've been looking at this new research from Tsinghua University and ByteDance, and they've built a framework called DreamID-V.
Right.
And their goal is, well, it's pretty ambitious. They want to take the amazing quality you see in still image face swapping IFS and just lift it directly into video.
And solve that flickering problem for good.
That's the idea.
But that jump from a static image to, a dynamic video seems to be where everything breaks down. An IFS model can give you one perfect frame, but when you stitch them together...
You get jitter, you get artifacts, there's no temporal consistency. Exactly. So they realized they couldn't just generate perfect video data out of thin air to train on.
But what did they do?
They created something really brilliant called the SyncID-Pipe. It's a data pipeline. And the core idea is, instead of trying to create new video data, they use the best existing image models to generate these bidirectional ID quadruplets.
So they're using the gold standard from images to teach the video model.
Precisely. They're training the video model on what a perfect still frame should look like. And to handle the motion, they have the identity-anchored video synthesizer, the IVS.
Okay, and that part handles the movement.
It's like a motion director. It uses what they call an adaptive pose attention mechanism, which basically locks in the motion from the first to the last frame, making sure the face moves coherently within the scene.
Here's where it gets really interesting for me, the architecture. I read that DreamID-V is the first VFS framework built on a diffusion transformer, a DIT model.
Yeah, that's a major step up.
So how does an architecture like that juggle all these different inputs? You have the identity, the background lighting, and all this complex motion data coming from the IVS.
It uses a very clever system called Modality-Aware Conditioning, or MC. You can almost picture the DIT as an intelligent switchboard.
Okay.
The MC makes sure that 3 different kinds of information, the context like lighting, the structural guidance for pose, and the core identity, are all injected separately. It disentangles them so the signals don't get mixed up.
That makes sense.
Yeah.
But starting with synthetic data, doesn't that risk making the final video look a bit fake, a little sterile or detached from reality?
It would, which is why they have a 2-stage training strategy. They start with synthetic data to get the identity similarity down fast, just teaching the model who it's supposed to be.
And the second stage?
That's the real augmentation training. They fine-tune it with real paired data and use this enhanced background recomposition to make sure it looks realistic and preserves the original background. It irons out all that artificial stiffness.
But there's one more piece, right? The thing that actually stops the flickering.
Yes, the secret sauce. It's a strategy called Identity Coherence Reinforcement Learning, IRL.
So wait, this is like a tutoring system for the AI. It actively rewards the model for getting the hard parts right.
That's a great way to put it. The IRL system identifies what it calls difficult frames. A quick head turn, a profile view, a big laugh. The exact moments where identity usually fails.
And it focuses the training there.
It gives those frames a massively higher learning weight. It basically penalizes the model much more for failing on the hard stuff, forcing it to get better at temporal consistency across the whole video.
And the results seem to speak for themselves. DreamID didn't just get better video quality. It actually surpassed some of the previous image models on identity similarity.
That's kind of wild for video.
It really is. And they released a whole new benchmark, IDBench-V, to go with it, basically setting a new standard.
So what does this all mean? It sounds like DreamID-V proves you really can transfer the power of these incredible image models into video as long as you can solve the temporal challenges. Exactly. And the framework itself is incredibly versatile. They've shown that you can just swap out the underlying image model and adapt it to other things.
Like what?
Like swapping outfits, accessories, even hairstyles, all in a moving video.
Wow.
So here's a final thought for you to chew on. Considering this diffusion transformer can handle structure and motion so well, what's the most complex non-face attribute it could swap? Think beyond just clothes or hair. Could it, for example, accurately transfer something really fine-grained, like the specific way a certain fabric winkles when someone moves? Or maybe even the texture of aging skin across a full range of expressions? Something to think about.